we're going to have a transformation. We're going to have two transformations. So our parent function is f of x equals the absolute value of x. That's the parent, the blue. Now we want to think about the child in the red. What are the transformations that are happening? So the first thing I'm going to identify is this plus 5. That's outside the function. So if I head back to my purple slide, outside the function, it's at the end, plus, what does it tell me? It's going to vertically shift up that many units. Here's what the rule does. It affects the y-axis and makes that vertical shift up. So if we head back, the verbal for that is a vertical shift or translation up 5. Just going to go ahead and write part of the rule now. Here's my xy. When we shift it up, remember we're adding 5 to the y-axis, or shifting it up on the vertical. All right, the other piece I want to circle is this minus 2. This minus 2 is inside the absolute value, inside the function. So we say we have to think opposite when we're inside. It has a minus, so there's a horizontal shift to the right that many. But again, make sure you see here, think opposite. So here's our rule. We're going to go to the right, so we're going to add. Add is the number. So we're going to add on the x-axis. So we say horizontal shift right 2. So if it's a right 2, we're affecting the x-axis. We're going to add 2. So there's now our rule, our verbal. Now let's head down. Let's go ahead and put a plus 2 here and a plus 5 there. This will be my g of x, absolute value of x minus 2 plus 5 at the end. My parent, remember, was the f of x equals the absolute value of x. And I did kind of preempt this slide already. You'll notice I graphed the parent function already. Remember, these values, when you evaluate it, look like this. All right, so there's that parent. Now what we're going to do is we're going to take all of these x values and add 2. So here's the first one, negative 2 plus 2, 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. All right, on the y values, we're going to now add 5. So 2 plus 5 is 7. 1 plus 5 is 6. 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. These are the graphed order pairs that will make up our new g of x function. And what it should do is it shifts right and up 5. So over 0, up 7. Over 1, up 6. Over 2, up 5. Over 3, up 6. Over 4, up 7. Here is our new absolute value function with the transformations. I'm going to call this my critical point. So that's my bottom of the V. And that point is 2, 5. Now domain. Domain, where on the x-axis does it exist? Negative infinity to positive. Every number works. Now let's head back up to our range. You'll notice right here on the y-axis, 5 is the number there. Everything above that yellow line exists. So we say then y is greater than or equal to 0. All right, let's scroll ahead. Another parent function, f of x equals alpha of x, same one. But now what's happening? We have a transformation. This transformation is a multiplier in front of the function. It's in front of the function. It's a multiplier. So if we head back a couple slides here, it's a multiplier in front of the function. it's going to affect the y-axis by that multiplier. So we have two choices, is it a stretch or compression? And what that means is, am I going to get taller or am I going to get wider? So I know it's something vertical, y-axis. And I have two choices. Either are we greater than 1 or are we a fraction? In this case, our a value equals 3. So we are greater than 1. So we're going to be stretching our vertical axes. And here's our rule. If we have our vertical axes, we're changing that y. We're multiplying everything by 3. So that's our rule. All right, so pause if you need to. Let's head back over to our problem. So here's our 3. That was our a, which equaled 3. Our verbal is vertical stretch by 3. We're multiplying by 3. When we write our rule, remember we said we're stretching the vertical, the y-axis. We're multiplying all those y's by 3. All right, so let's head down. Here's our g of x. 3 times the absolute value of x. We're multiplying all the y's by 3. F of x, absolute value of x. When we evaluate it, we're going to get 2, 1, 0, 1, 2. All right, we are changing all of these y's by multiplying by 3. So 2 times 3 is 6. 1 times 3 is 3. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6. Are we doing anything to the horizontal axes? No. So all of these values are still the same. So just repeat that column. -2, -1, 0, 1, and 2. Now let's graph these 5 ordered pairs. -2, up 6. -1, up 3. 0, 0. 1, 3, 2, 6. There is our new function for our g of x. Notice it is stretching it vertically. It's making it taller. It's making it skinnier. Our domain, again, is the same. -infinity to +infinity. But now our range, we go across our horizontal axes. Everything above y equals 0 is true. So we say the range then is y is greater than or equal to 0.